Good morning, everyone. Today we're going to continue our discussion on multiple linear regression. So these are the packages that we're going to use, at least some of them for today, and then we're going to use some of them in the next sessions. Okay, so I have your psych package, HMISC, Broom, Tidyverse, PaceText, Desk Tools. Many of these are for descriptive statistics, SCIM-R, OLSRR, card, GG-Ally, GG-Fortify, and Stargazer. This is for creating tables. Okay, so I shared with you last time the wage data set. Okay, so we said that it's best for you to load the data set in your R project for easier access. So let me just, okay, have I run this? Just making sure that I run. Okay, so how do you load a file that's saved in your saved in your project? It's very easy, class. We can make use of the read R package, and that's with the tidyverse, and make use of this read_CSV. Now, the advantage of saving your file in your project is that you just have to identify the file name. So inside my R project is the wage data set here. It's already saved here in my files in this project. So when I load it, I just use read_CSV because this is CSV file. And then I just identify the name of the file, wage.csv. And then, then we say that column names is equal to true. Okay, I'll give you a few seconds to do that, class. Sorry, just get water. So once we have loaded the file, class, we can check the file. We can view it. Okay, let's view the file, class. I haven't run this. Let me load the file first. And then I'm going to see that I have the wage data set here. Okay, it's here. It's a data frame. In fact, when we loaded it, class, we were given some information about it automatically. So this is the code that we use. Okay, and then it has 526 rows of observation and 14 columns. Okay, and then some information about the data. Okay. So we can view this by clicking this one. So we have here, oops, sorry. Wait, no? Wait. Looks like may nadagdag sa file comment. Okay, hold the line, class. Let me just fix this. Sorry. Sorry, class. Another column was remained, so I had to delete it. Okay, so I had to like select columns 2 to 9. Okay, there you go. So this is now our wage data set. Yeah, oh, sorry. Okay, so that takes care of the uh, data set that we're going to use. Okay, and then let's take the structure of the data. Okay, so it's a table, 526 by 8 is the size. You have education, experience, and tenure. They are numerical variables. Race is, sorry class, medyo yung ubo ko. Race, gender, and uh, civil status. Okay, you have character variables there, number of dependents, and hourly wage. So this is our data class, and we'd like to uh, perform multiple linear regression here, where the dependent variable is hourly wage, and the rest are independent variables. Okay. Okay, so once again, class, by way of review, okay, this one, dollar education, means that you can only access this through the data set wage. And if we get, for example, the mean of education, we won't be able to get it, okay, because, okay, wait, sorry. Okay, so we said that this will not run because we will have to go through, we will have to access education through the object wage. Education does not exist in the objects here. Okay, there's no education here. It does not exist in our environment. So if we're going to access education, it has to be through wage. So we did it last time. And then we said it's important for us to know, since we're going to do multiple linear regression, we would like to establish the relationship between your independent variable and your dependent variable. So we can make use of this package called from psych package, the pairs.panos. And if we run this, and we have a plot where we have the all the variables, and we have the correlation matrix. So the upper part here is the correlation matrix. This one is the plot, the diagonal is the plot of the variable itself. And then here, you have your scatter plot here below. And however, this contains the asterisk here are all character variables. And we said that character variables do not really have quote unquote correlation with their variables. So why does this have a value? For example, si race. Bakit may 0.08 siya with education? Because race was converted into, automatically converted into factors by R. So which means that it has numbers. The race is represented by numbers. And what are the races ba? Saan natin? We can use table, wage, race. You can see the distribution of the data. So we have non-white at white, no? So what's happening here is that R automatically converted the non-white and white into numbers, either 1 or 2, 0 or 1, it depends. Okay, so that if these are now 1 and 2 or 0 or 1, then these have been converted into numerical, quote unquote, integers or numerical values. So we can get the correlation. So this one, class, is a correlation by converting the race into numbers. But again, class, this has no meaning. So it doesn't make any sense for us to include this race, gender, civil status in our correlation plot. So we can come up with another one where we just select, okay, so this one we did last time, we selected all the quantitative variables, education, experience, tenure. So we selected it. So we created this object wage1 from the wage data set. And then we used here GG pairs. No? We could have used also pairs.panels, but let's run this. Okay. And hindi siya nag-automatic plot, no? So, minsan itong GG alay, medyo ano. Hindi siya nag-automatically mag-plot. So let's just, I'll just replace this for a while. Ito. Okay. I'll just use here. Ayaw mo. Okay. Okay, class. Control C. And wage1. Wage1 siya. Kasi this is the object now. There's the panels. Wage1, control enter. Okay, ano nangyari? There's the panels. Hindi ko pa naroon itong wage1. Wage1. At nag-error ako. Wage1. Large. Wait. Sorry. Let me run my wage1 again. Kasi kanina class, I continued it, no? Yung wage1, tuloy-tuloy sa GG Ally. So let me run again my wage1 here. There. Okay. There. Okay na siya. 5 variables. So pairs.panels. We have another plot here. There. Okay. So this plot now remove the character variables so that ano na lang siya, no? Numerical, and we can see here the correlation between hourly wage and all your independent variables. If we're going to choose only one independent variable to try to explain hourly wage, then the option would be education. Education having the highest correlation with hourly wage. And the least would be number of dependents. Kasi si number of dependents class, 0.05 lang correlation niya with hourly wage. Okay, if we were to choose two, education and tenure. Okay. Pangatlo yung si experience. Okay, any questions here, class? We did this last time. It is clear so far, class? Kindly chat, please. Any questions? Clear so far, class, yung correlation plot natin? Okay, thank you. All right. So, by the way, kasi in diagonal, ito yung ano, no? Ito yung distribution ng variable natin, education. You can see here the plot, okay, of the variable, and then below are your scatter plots. That's a plot. Let's say this one, education and experience. You can see that it has a negative correlation with it, and that's specified here, negative 0.3, ano? Tapos yung plot niya, kita natin talagang pababa, no? So dito naman, okay, for education and tenure, okay, it's negative 0.06. And then you can see here that it's practically no correlation, no? Okay, straight line lang. Okay, then here class, this is now, so I can now run this from the GG Ally package. We have GG pairs. I prefer this actually, no? Itong GG pairs na plot. Okay, it looks a lot better than the pairs.panels. One. Yan. Mas ano siya, mas let's say mas better for a publication, no? Okay, kasi dito nakasabit lang yung mga variables, di ba? It's stated here. Dito kasi huhulaan natin di ba? Ito, tenure with ano ba to? Ito, kunyari, hahanapin mo pa, no? Tenure with experience. Ito, it's already identified. Okay? So tenure. Andito din sa ano sa vertical bar, no? So this is tenure with education. We can easily see that. And here it includes the significance, kung significant ba yung correlation niya. Kasi dito, okay, hindi significant, hindi statistically significant. While for the others, the ones with the 3 stars, they are statistically significant, which means that we are confident that these values are not equal to 0, okay, statistically. Ito naman, so it means that the values could be statistically, they're equal to 0. So we're not able to reject the hypothesis that the values, the correlation is equal to 0. Okay, so let's continue now. Okay. All right, so this is just we're going to start conceptually, titingnan natin class yung simple linear regression lang muna, no? We're going to use education as a predictor of hourly wage. Why education? Kasi based on the correlation class, education, as I said, if there's only one predictor that we're going to use, the best is education, having the highest correlation with our dependent variable hourly wage. Okay, so let's plot again, although we have already a plot. Ito yung scatter plot ni ni education at saka ni hourly wage. Okay, asan yung scatter plot nila? Education, hourly wage, ito, this one class. This one, education and hourly wage. This one is a scatter plot. So you can see that in fact the correlation is positive. Positive in correlation, okay, somewhat like this here. Yan. Okay, and it's equal to ito, no? 0.41. Okay, and it's statistically significant. So let's just replicate that plot by using the plot function. Okay, here class, plot wage education. This will be the x-axis, and wage hourly wage. We cannot directly say education and hourly wage because it will not be understood by R. Okay, so if I run this class, you'll have that plot there, okay, which is just a replication of this one, diba? Pareho lang siya. Okay, let me pause for a while, class, and allow you to catch up with the code itself. You can see, class, that whatever is placed here will be your x-axis, no? Ayan, wage education. Andito si wage education, si hourly wage ito. Okay. All right, so this is the first linear model that we're going to construct, no? So we're creating this object called mod1, and it's equal to LM. LM stands for linear model, and this is let's say, ito yung pinaka-power horse ng regression, linear regression. LM, linear model. Later on, we will be using GLM, generalized linear model. And how is it done? You first identify the dependent variable, and then this one, tilde. This is nasa to the upper left, below escape. This means associated, no? hourly wage is associated with education. Okay, so and then it's okay just to identify the variable hourly wage and education kasi we're defining here naman the data set. Data is equal to wage. Okay, so whether you use the wage data set or the wage one data set, it's okay kasi pareho naman ano dun yung education. So but let's just use the wage data set. Okay, and then if I run this first, control enter. Ano nangyari? Bakit ano? Unexpected saan? Huh? In hourly wage. What happened here? Waiting po ah. Hourly wage. And data is equal to wage. So, andito naman yung wage ko. Okay? Okay. Weird nitong R ko ngayon. Ah. Okay, so I hope you got it, class. And then notice, class, that the object that I created, model 1, mod 1, it's a list. No? So, tingnan natin tong list na to. A list, class, will always be part of your data. Okay, if we can see here, class, marami siyang laman. No? Okay, ito yung si model 1 natin. I can hide this. Okay, ito siya. 12 elements inside mod 1. So, ano yung mga laman niya, class? Andyan yung coefficients. So, ito yung coefficient class. No? Andyan yung residuals. Andito yung effects. No? And then, fitted values, these are your forecasted values. Okay, and then so many others. However, class, we're not going to discuss this in greater detail kasi doon tayo magfo-focus sa multiple linear regression. Ito, class, this was just meant kasi simple linear regression to eh. So wala masyadong value sa atin yan. I just wanted to, at least as an introduction, how the LM function will work. No? So when we create, class, a model, whatever object, and then we're using the LM function, it will create a list. And inside that list are these the elements, andun yung coefficient, class, as I showed you, andun yung residuals. So yung computation ng residuals, andun na rin, class, sa model 1. And in fact, we can generate the summary of this by using the summary mod 1, class, tingnan natin. And then here you have, okay, so this is the formula that we use, LM, hourly wage regressed or associated with education. Data is equal to wage. And then you have here the descriptive statistics for your residuals. Okay, so telling us that it's important, class, yung residuals, importante yon. Okay, so in fact, the diagnosis, checking if our model is okay, will be primarily be focused on the residuals. Okay, as we know, the residuals is the difference between your actual value and your predicted value, your model value. And this is the solution, class, here. So we can see here, and the coefficients natin, no? Since we only have one predictor sa education, only one will appear here, plus the intercept. So this is the value of your intercept, this is the value of your education. Okay, and then you have standard error, t-value, and then the probability. All right. Now, as I said, we're going to discuss more yung meaning ng mga to when we go to multiple linear regression. Ito, let's just note that R generates this output, and then we will be focusing on how to interpret this when we go to multiple linear regression. Okay. All right. This one also, we'll discuss that. Suffice it to say, class, that ito, no? Minesh yung standard error, 3.378. on 524 degrees of freedom. So, saan nanggaling tong 524 degrees of freedom? The formula, class, is to compute for the degrees of freedom is n df, class, degree of freedom is equal to n minus k minus 1. Okay? Where your n is your number of observations. Yung wage data set natin, 526 observations. Okay? K is your number of predictors. Ilan yung predictor natin? Sa education lang, di ba? So this is 1. And 1 is for the degree of freedom lost because we're computing for the intercept also. So this will account for the degree of freedom that we lose for including in our computation the intercept. Okay, so that's why 526 minus 1 minus 1, you get here 524. If in the next round class, magre-regression ulit tayo, tapos we have, let's say, 5 predictors, in that case, class, what will happen is n minus 5 minus 1. So that's 526 minus 5 minus 1, so that would be 520. So if we're using 5 predictors, class, the degree of freedom will be 520. Okay? Okay, then, ito na lang, class, no? Ito. 16.48 or 16.42, we'll study the distinction later on. This just means that yung model natin, okay, our model which uses education, diba? Si education yung ano natin. Education is our independent variable that we're using in trying to explain hourly wage. Okay? We're trying to explain hourly wage using education. This tells us that around 16% of the variability of the variation itong hourly wage can be explained by education. So 16 point, based on multiple R squared, 16 point around 16.5 squared lang. Based on adjusted R squared, around 16.3. Okay? 16.3 lang. Paano yung ibang yung 83% na hindi ma-explain about hourly wage? Then most probably, it could be explained by other variables. No? But as far as education is concerned, ito lang kaya niyang i-explain. 16.4, 16.3% based on adjusted R squared. Okay? So yun muna, no? And then let's now, okay. So let's move on here. Okay. Now we can actually take a look at how this was computed. No? Okay, let me share this with you. Itong equation na to. Ito kasi it computes for this is the formula to compute for the slope. Okay. Formula to compute for the slope, okay? So that's beta 1 is equal to your x, x sub I minus x bar times y sub I minus y bar. Okay, and then you have here summation of x sub I minus x bar squared. Okay, and as I said, class, we can prove that this formula is your beta 1. But this is just simple linear regression. So as I said, hindi natin titinan siya masyado, no? Pero although andi dito, no, ginawa namin ito eh. Pero sige, i-ano na lang natin. Just for purposes of, just purposes of example. Okay, I'll just give you the code here. Okay, so let's just quickly follow this. Okay, so si xi class, this is your independent variable. Your y sub I is your dependent variable. So each of the elements of your x's, ima-minus natin yung average niya. Okay, so this one, x minus x bar. And then i-cross multiply natin siya with yung y naman, which is hourly wage minus the average of hourly wage. So each of the observations, iba yung wage natin ito. Okay, so as a education ito, no? So 11 minus ano yung average na education. Okay? And then i-multiply natin sa hourly wage minus the average of hourly wage. So that's what that formula is doing. Okay, x sub I minus x bar times y sub I minus y bar. So we're going to cross multiply that. Okay, for all of the observations, and then isa-sum up natin. Okay, so that's what that formula is telling us, class. Okay. So let me show that again. Ito, no? Ito yung individual values ng education natin minus the average, then cross-multiply it with the individual values ng ni hourly wage, subtract centered on the mean minus the mean. Okay, then isa-sum up natin lahat yun. And then, yung kay x lang, x minus x bar squared. Actually, class, just to show you, class, this one is actually, ito, class, divided by, ano to? Divided by n minus 1. No? Divided by n minus 1 yan. And ito din, class, divided by n minus 1 to. So that's the complete formula. So when you get this cross product, sum mo, tas divide mo ng ng 1, that's actually your covariance. That's your covariance ni x and y. Okay? Covariance x and y. Okay, which is also can be written as sigma x y. So this one, class, is your covariance ni x and y. Ito naman, class, ano to? This is your variance of variance of x. Variance ni x. So actually, class, the slope is equal to the covariance divided by the variance. Covariance between x and y and the variance of x of your dependent variable. Okay, if you recall, class, formula ng ng variance to. Okay, square root ng x minus x bar squared over n minus 1. So in effect, class, the slope is simply equal to the covariance between x and y divided by the variance of x. All right, so let's just quickly pakita lang natin, no, for purposes of discussion. So how do you do this? Very easy naman sa R, no? So let's let x1 be yung wage, yung education. Our y1 will be your hourly wage. Diba? So we're now creating an object called xi, which is the wage of education. And then y sub I is the hourly wage ng, sorry, baliktad, no? Education ng data na wage, itong si x sub I. Tapos si y sub I will be the hourly wage data of the hourly wage column ng wage data. Okay? So na-create natin to, may x sub I na tayo. So if I check this, class, check mo yung x sub I na to. Yan, no? 11, 12. It's a vector. It's a numerical vector. So tingnan nyo kasi wage. Diba? Yan, no? 11, 12, 11. Yun siya. Okay, so yun ang x natin. Tapos ganun din si ganun din si y. So this will now be your hourly wage. No? Yan na rin siya. No? Ito yung hourly wage natin. Tapos kunin natin, class, we need the mean, di ba? Yung formula na to. X bar, both. So we need the x bar, which is the mean of education, and y bar, which is mean ng hourly wage. Okay? So ang formula, simple lang. No? Our beta 1 is equal to the sum of ito, di ba? Xi minus x bar. Tapos times yi minus y bar. Y bar is the mean. Okay? Close natin to kasi sum niyan, no? Diba? Sinasum natin yung cross product nito. And then divided by the sum of x sub I minus x bar squared, which is the variance. Nakasum din yun. Okay? So if you run this, class, and print it, kaya nga may quotation, may parenthesis, the parenthesis here, ito, parenthesis dito, will result into printing the result. Okay. So this one, class, 0.54. Okay. So check natin na Control Alt I. If we get Model 1 class, Model 1 dollar, ano ba laman ni Model 1 class? Ito mga to. Si coefficient andyan. Okay? Coefficient. Tapos, ano kay coefficient? Kasi dalawang coefficient eh. Yung una, yung index. Tapos yung pangalawa, yung slope. Tingnan natin to ha. Okay, there you go, class. So we were able to access, no? Saan nanggaling yan? Kay Model 1. Paano mo nalaman? Di ba yun yung pangalan? That's the name of the object that we created. Model 1 here. Okay, tapos ang mga laman ni Model 1 ito. Coefficients, residuals, effects, etc. Okay. Coefficients class, ito yung result. No? If I click this class, yan, no? Intercept. So this is under coefficient, ito yung first element niya. And then second element niya is education, 0.454. That's why class, when I access it, mod 1, dollar coefficient, and then I need the second one. Yan. I'm subsetting the second one. Okay, and exactly the same. So pareho class yung result ng dun sa formula na generate natin. Okay? The reason why we have to familiarize ourselves with this kasi class sa mga future lessons kakailangan talaga natin yung mga formulas. Kunyari when we reach time series, we have to know, for example, the formula for yung basic na random walk. Okay? Ano yung formula ng white noise? Okay? Ano formula ng isang AR process, AR1 process? So we have to know the formula, we have to know the limitations, and it pays class to know how to work around formulas in R. Okay, any questions, class? I might be going too fast. Kindly give me your feedback, class, if you're able to follow, or if you need me to repeat something here. Thank you. Well, let's wait for the others. Good. Good. Okay. So I want your class to be comfortable with navigating through R, no? Whether it be function, simple function, or just a formula like that, no? Okay, sige. Let's move on, class, kasi hindi naman talaga simple regression yung gusto natin. May iba pa ba ako ditong kinompute? Okay, so ito lang naman, class, no? Pwede rin naman to, kasi di ba yung formula natin, lagi natin sinasama si wage. Wage, dollar, education. Laging kasama si wage kasi nga, R will not be able to access si education. So is there a way to create, for example, X sub I na hindi na natin ina-access sa wage? Pwede yun, class. And how is it done? This one, class. Sige, I'll share this code with you. Control C. All right. So what's this, class? The use of attach. Okay. Pag nag-attach tayo, class, ibig sabihin ng class, attach wage. Whatever variables that we're referring to will be coming from wage. Okay, so no need to use wage dollar education. That's why take a look at this, class. Parehong formula lang to, class, no? Pero tinanggalan natin yung ano. Although dito kasi, nag-create muna tayo ng X sub I. Diba? Yan, no? X sub I is, XI is wage dollar education. So technically, class, this formula is also wage dollar education. Kasi X sub I to, which is just wage dollar education. Okay, but if we want to dispense with the use of wage, pwede to, class. So i-run nyo to, class, attach, no? Control Enter. Attach, class. Ibig sabihin, we're telling R, any variable that we're going to use will refer to wage. Kaya tinan nyo dito. Sum ng dito. So dito, class, education na lang, oh. Minus mean of education times hourly wage minus mean ng hourly wage. Okay, and then divided by sum ng education minus mean ng education squared. Okay, so now, okay lang yan kasi naka-attach si wage eh. So R will understand that this variable, education, and then hourly wage are all coming from the wage data set. Okay, so let's run this class, control enter, and then there you go. You have also negative 0.54. All right. Okay. Which is also equal to, di ba kanina sabi ko, actually yung slope na yan, it's just your covariance divided by the variance. Di ba? If you recall the formula kanina class, kasi x minus x mean times y minus y mean, di ba? Summation of that. If you divide that by n minus 1, covariance na yun. Covariance ni x with y. No? And then i-divide pa natin ng x minus x bar squared, summation nun. Tapos divide mo rin ng n minus 1 yun. That's your variance. Magka-cancel lang n minus 1. Okay, so ito, pareho lang yun. No? Covariance, education, hourly wage, divided by the variance sa education. Pakitry nyo nga class if you get 0.54 also. I won't share that with you. Type nyo lang, maiksi lang naman yun. Okay, so what did you get, class? Same? That's good. Good. So either use the formula, but we know that that formula is actually a simplification of this one. Pero ang tanong, bakit nawala yung n minus 1? Kasi na-cancel lang, class. Okay? May n minus 1 talaga yan. Kasi covariance to eh. Kasi ito naman variance. Covariance ng x and y, ito naman variance ni x. So, kinancel lang yung n minus 1. But the complete formula is really may n minus 1 dito, may n minus 1 dito. That's why you can say that it's a covariance of x and y divided by the variance of x. Okay, class? Any question? Any question, class? No question? Okay. Now that we have solved for B1 class, the slope, yun ang una sinusolve. Tapos masosolve na rin natin si control. Share ko na tong LaTeX na to. Masosolve na rin natin class si oops, sorry, mali. Control C. Okay, masosolve na rin natin class si si intercept class. So after we solve for the slope, we can solve for the intercept. And it's just equal to, the intercept is just equal to the mean ng dependent variable natin minus the slope times the mean of the independent variable. That's why, class, sabi natin yung sa first principles natin, the regression line will always touch the x bar, y bar. The mean of x and the mean of y. Lagi yun, no? Laging kasama yun. Okay, so this is very easy. I want you to now write this. Okay, kasi ano lang naman yun, ano? Mean lang ng hourly wage, ito yun. Yan. Mean ng hourly wage minus beta 1 times mean ng education. Again, class, since naka-attach pa si wage, di ba? Pwede natin diretso yun na mean of hourly wage. Okay? So let's run this. Okay, so it's -9. Check lang natin, Control Alt I. Yung mod 1, okay, kanina ginawa natin dollar. And then coefficients. And then yung first one, 1. Yung first kasi na value doon is your intercept. Control Enter. Okay, there. So parehong-pareho, no? Parehong-pareho. So we were able to show that yung formula naman ng slope, ng intercept is just the mean of your dependent variable minus the slope times your independent variable. Okay? So, sige, class. Any pa-feedback naman, please, kung okay na. I want us to really reach multiple linear regression. Can you please give me feedback if okay na tayo? Okay so far, no? Thank you. So let's wait for the others. Okay, good. Good. All right. So I hope no questions, class. I hope you're able to follow. Okay. Okay, let's go now to interpretation. Okay. Next, this one, standard error. Wag na muna natin, class, i-discuss itong mga standard error. Standard error when we go to, this one also, T-stat. Let's discuss these things when we go to our multiple linear regression. Okay. All right. So let me skip those things, class. And then, okay. 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 Sorry about that. I shouldn't have included that here. Okay. Okay, class, kasi ito, ginamit ko to ng ang ano lang talaga, simple linear regression. That's why there are so many things here. But remember, we're not really going to use, we're not going to use simple linear regression. Pupunta tayo sa multiple linear regression. Okay, so sige, dito na tayo, class. Sorry. Apologies for this, class. I used the wrong file. Dito na tayo, class. Okay. So let's now, sabi natin, class, kanina, yung model 1 natin, class, 16% lang. 16% lang ng variability ni hourly wage, independent variable natin, can be explained by your independent variable. Okay, so that's very low. And based on researches, there are other factors that affect hourly wage, included not only education, but experience, tenure, maybe the race, gender, civil status, number of dependents. So what we're going to do now is we're going to create a model, new model, model 2, but this time we're including all, lahat na ng mga predictors. Okay? So lahat ng mga predictors kasama. So sige, class, regress hourly wage on all the other independent variables. I want you to write that one. Okay, ito po yung ngayon ng bagong ng new code chunk. Okay, and then please tell me what happened when you run this. So model 2, no? And then i-summary natin, class. Model 2. Okay, and run this. Okay, so once you have run that, class, kindly chat yes, please. Let's see what happens. Let's analyze, class, kung ano yung model 2 natin. Our model 1 was just a simple linear regression. So, kaya nga 16% lang yung kayang i-explain. Ito naman, model 2 natin, lahat ng available na regressors. Tingnan natin kung sino mas maganda. Si model 1 ba o si model 2? Okay? Sige. Paki-chat please if you were able to run yung model 2 natin. Okay, good. Okay, good. Sige, so let's compare. By the way, class, this one, writing all the predictors is the same as this one. Hourly wage tilde dot. Okay, if you're going to use all the predictors in your data is equal to wage. And instead of writing all the predictors there, kunyari kung 20 yan, ang dami yan, di ba? You can just write that, which means all your predictors. Okay, so just so you know, kasi baka may makita kayong ganyan na nagre-regress, tapos bakit kaya that yun? that means all the predictors there. Of course, except hourly wage. Kasi ito naman, dinidefine natin si hourly wage as our dependent variable. So let's run mod 2, and then let's get the summary of this. Control Enter. Okay. So we now have mod 2. Si mod 2 natin, okay, list pa rin siya, no? Tapos 13 siya. 13 yung laman ng list na to. So if we inspect this, it will mostly have the same elements as mod 1. Take a look at this. Nadagdagan lang ng isa, no? There. Coefficients, residuals, effects, ranks, fitted values, etc. So quite a lot of data information that we can have from mod 2. Okay, so tingnan natin class yung, let's see the summary. Ano nangyari sa summary? Okay, here. Ayan, class. All right, so this is where we will be focusing on yung multiple linear regression, hindi yung simple. So let's take a look at this class, no? All of our variables are here. Education, experience, tenure, race, gender, civil status, and number of dependents. 1, 2, 3, 4, 5, 6, 7. 7 predictors class. Lahat sila andi dito. Okay, first, tingnan muna natin class. Okay, let's first test. Okay. What's the meaning of this? Education muna, no? 0.57. We didn't discuss this kanina sa simple kasi sabi natin, magfo-focus tayo sa multiple, no? 0.57, tapos may standard error tayo dito, tapos may t-value tayo, tapos may p-value tayo. So, ang goal natin, class, is for us to be able to understand each of this. Okay? Paano nakuha tong estimate na to? Paano nakuha si standard error? Paano nakuha si t-value? How about the probability? Anong ibig sabihin nito? So, let's start with this one, class, education. And what's the meaning of 0.57? Okay, I'm rounding it off, 0.57. Okay, so 0.57 stands for, guys, ano meaning? We should be able to interpret this. Ibig sabihin nito, class, that for every 1 year increase in education, notice I said years. Bakit years? Kasi yung education natin, class, ang dimension yan in years. So when you read this variable, kailangan you have to know the dimension. The education is in years. So pag binasa natin to, for every 1 year increase in education, there's a corresponding, so take note, there's a corresponding 0.57, okay? There's a corresponding, since yung dependent variable natin is hourly wage is in dollars, so babasahin din natin to in terms of dollars, okay? So there's a corresponding 0.57 dollars or 57 cents. Okay? And since this is positive, no? Positive siya. So increase ka rin dito. Pag nag-increase daw si isang year na education, may corresponding na 0.57 dollars increase in hourly wage. Okay. Hourly wage. And then you have to put here ceteris paribus. Okay, explain ko ulit, no? So this one, class, in estimate na to, is the marginal effect of education, okay? Marginal, which is 1 unit increase in education, and the 1 unit increase in education will have this marginal effect on your dependent variable, hourly wage. Ceteris paribus, which means all things being equal, all things remaining the same. Ibig sabihin kasi dito, di ba, 1 year increase in education. Yung iba, wag mong i-increasean. Okay? So we're not increasing experience. We're not increasing tenure. We're not increasing number of dependents. Ang ini-increase lang natin si education. Pag nag-increase si education ng ng isang unit, anong unit na yun? Years. Okay? Si hourly wage daw, magi-increase ng 0.57 dollars. Ceteris paribus, which means all things being the same, do not change, do not increase or decrease any of the other variables. It's only education that we will be increasing. Okay? All right, and then we can see here, notice that this one class, the 3 stars here indicate that this is statistically significant. No? Now, statistically significant to what? Ano ko muna to, no? Dito class. Dito natin makikita yan. Here. So sa R class, take note of this, no? Okay. So itong 3 stars na to, ito yun. 2 stars ito. 1 star, this one. This is dot, and this is nothing. No? So it means, class, that this value is statistically significant to 0.001. Okay? So in other words, class, yung we're certain, no, that up to the 0.001, okay, that's 0.1% level of significance, that this is a value not equal to 0. Okay? Kasi class, ang nangyayari dito, this is an inference, no? This actually is a statistical test. Anong tinetest natin dyan? Ang tinetest natin dyan na si B, this is your slope, okay? Si B, this is B1 is, tinetest natin to, that B1 is equal to 0. Ang sinasabi natin, si intercept 1, si slope 1, which is education, is equal to 0. So, since our p-value is significant at 0.001, ibig sabihin, the value, which significant at 0.001 plus level of significance, which means that this value is practically 0. No? The probability that it will be equal to 0 is practically 0. Hindi siya pwede maging 0 class. Yun ang bottom line na sinasabi nun. So we're certain that your slope, yung effect ng education and hourly wage is a number other than 0. It's not equal to 0. So may value siya. Okay? Pause muna ako, class. Clear ba yun so far? Don't worry, class, kasi first discussion pala naman natin to, no? Yung next few weeks pa na ganito tayo, no? Pero at least, class, naintindihan ba? Okay, repeat. All right. So ito, class, we're taking a look at the impact of education on hourly wage. Okay? Itong table na to, it tells us that for every 1 year increase in education. Now, why am I saying year? Because you take a look at the dimension of the variable. The variable here is education, and this is expressed in years. Okay, so that's why we have to use years. No? So for every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage. Okay, so we're looking at the marginal effect of education on the dependent variable, which happens to be hourly wage in this case. Okay, and then we ask ourselves, is that 0.57 statistically significant? Okay, kasi baka this might be 0. Because if this is 0, it means that education has no impact on hourly wage. So where do we go? We go to the p-value. Okay, the p-value here indicates that this one is a statistical test, and from your stat before, you know that in a statistical test, you have your null hypothesis, yeah? And your alternative hypothesis. Okay, the null hypothesis here is that your B1, okay, why B1? Because your intercept is B0, no? B1, B2, B3, B4, B5, B6, B7. Okay, each of these can be denoted as B1, B2, etc. So the null hypothesis for education is that B1 is equal to 0. Okay, so we're testing that. We're testing if the slope for education or its effect on hourly wage is equal to 0? The answer is we are rejecting that. We reject the null hypothesis that B1 is equal to 0. What's the basis? P-value. Actually, dalawang basis class. No? Number one is the P-stat, which we're going to discuss next meeting. And then second one is the P-value. Mas madali class yung P-value. So we just compare the P-value with 0.05, which is the usual level of significance again that's used. Okay, if your P-value is less than 0.05, then the inference is that we reject this null hypothesis, that your intercept, that your slope for education is equal to 0. Okay, why are we rejecting it? Why are we rejecting that B1 is equal to 0? Because the P-value is less than 0.05. Okay, this 2e to the minus 16 is actually, how do you write this? So e to the negative 16 plus means you move 16 places to the left. So from here, from 2, move 1, 2, 3, 4, 5, 6, 16 places to the left. So that's actually 0.00000, 15 zeros, and then 2. Okay, so that's the value of your P here. And since P value is way, way less than 0.05, then we reject the null hypothesis. In fact, the standing rule is that, okay, remember this, when the P is low, class, when the P is low, the null must go. When the P is low, when I say low, you compare it usually with 0.05. When the P is low, the null, this one, must go. Ibig sabihin, reject. P is low, null must go. Okay, so it's important to know the null. Here, the null is your beta 1 is equal to 0. And here also class equal to 0 din yan. Okay, take a look at experience class. Experience 0.02. No? So what does that mean? If you just take a look at this, it means that for every 1 year increase in experience, there's a corresponding $0.02 increase in hourly wage, ceteris paribus. Don't forget the ceteris paribus. Which means that you only increase experience by, it's only experience that you will let increase, no, by 1. The others, education, tenure, etc., you're not going to change them. It's only, we're only taking a look at what will happen to our hourly wage if we increase our experience by 1 year. Okay. However, class, before we can check that, we have to look at the p-value here. Okay. So remember that this is also a hypothesis. The hypothesis here, our H2O here, will be B2 is equal to 0. So we'd like to test if the slope for experience is equal to 0. So where do you go, class? You go to either the t-stat or to the p-value. Now, if you check the p-value, class, this is 0.07. And take note, class, this is 1 dot, no? What does that mean? Ito, class, here. That this is significant, but at 10%, 0.1. Okay, however, if we're going to stick to our basis level of significance at 0.05, okay, so what happens, class? Rule, if the P is low, the null must go. When we say low, class, we're comparing it to 0.05. So is 0.07 less than 0.05? No. Okay, no. Therefore, what's our inference? The inference is that we fail to reject the null hypothesis that your beta 2 is equal to 0. We cannot reject that. But because we're not saying that B2 is equal to 0. No? We're just saying that we can't find any evidence, but that B2, we can't find any evidence that B2 is not equal to 0. Medyo, I hope. This is just more of your stat nung dati, no? This is your basic statistics. But we're just putting it in the flesh here. Okay, clear tayo, class, so far? Okay, does that answer your question? Okay, thank you. How about the others? I want the others to please give their feedback. Okay, good. All right. So going down the line here, class, you can see this one. So let's focus on this one, gender male. Okay? As far as I recall, class, yung gender natin, class, let's go to range. Parang wala naman tayong gender male na variable. Tingnan dito. Gender. Female, male. Okay? Female, male. Okay, so what happened here? What happened? Bakit, class? Why is it that yung variable ko dito sa R natin naging gender male? Okay, so what does this mean, class? What does this mean? So what happened here, class, is that you can see here, technically, since these are these are categorical variables, so what R did was automatically okay, to make this as your to make this what we call as dummy variables. So ginawa niyang dummy variables to, dummy variables. So when will R make this as a dummy variable? If you have a categorical variable, okay, which can be considered as a factor. So take note, class, not all categorical variable or not all character variables can be considered as factors. Factors are those categorical or character variables that can be used for classification. Okay? All right. So, Pau, may sinabi si Pau, no? Pau, can you please, can you please share your answer to everyone here? Okay. Paki-explain mo what you mean by, male as the reference variable.
In this case po, sir, since gender is a categorical variable, R treated it as a dummy variable, and in this case, it assigned 0 and 1 to the gender. However,
Yeah.
when you're regressing with dummy variables, you need to have one of those dummies as a reference po.
Yeah, oo. Ang
So,
question, sino yung 0? Sino yung 1?
if I'm not mistaken if I'm not mistaken with R, ginawa niyang 1 in this case is yung female, ginawa niyang 1 is yung male po.
Okay.
Tapos
Ano yung basis? What's the basis for that?
kasi yung nakalagay po sa variable name is gender male.
Oo, pero bakit si male ang ginawa niyang ang benchmark niya si female, no?
Yes po, sir.
So, bakit si female ang ginawa niyang benchmark?
That
Pero
that po, sir, I'm not sure po sa
Oo,
architect.
sige. Okay,
Kasi,
but Pao, you're correct, no? You're correct. Tama si Pao, no? So, i-reinforce lang natin sinabi ni Pao. Pao said a while ago that for factors like this, for character variables that can be considered as classifiers, take note, no? Classifiers to. We can classify. Yun ang importante dito, yung operative word. So, female and male can be classified, di ba, into male and female. So, what R does here is that it will look at this, itong gender na to. First, it will take a look at the levels, no? How many genders are there here? So, makikita niya, female and male lang, no? So, it sees that there's only female and male. All right? So, what will now happen is that female now, since it appears alphabetically first, no? So, i-alphabetize na siya. So, si female ngayon yung magiging benchmark, no? Okay, when you say benchmark, it will be compared to the female. All right? So, what will happen is that R will now introduce what we call dummy variables. Dummy variables, which is usually 0 and 1, to represent your factors. So ano nangyari dito, class? Female, okay, female appears first alphabetically. Diba? Kasi female and male lang. So female will now become your benchmark. So your benchmark, what value will it have? 0 or 1? 0 or 1 class. Okay, so benchmark class, yung reference, magiging 0 yan. In other words, class, lahat ng gender dito, lahat ng female, 0, 0. So si 1 lang yung magiging, si male yung magiging, male will become 1 here. All right? Okay, now, there are 2 levels, no, female and male. So the question is, how many dummy variables will be introduced? It's always the number of levels. So level minus 1. So since there are 2 levels here, female and male, then R will only introduce 2 minus 1 dummy variable. So in other words, this gender class will be replaced by 1, 1 variable. Okay? Yung variable na yun will consist of 0 and 1. Okay, let me clarify that. Suppose we have a variable that has 3 levels. For example, let's just, for purposes of example, level A, so you have 3 classifications, A, B, C. Okay. What will happen if you have 3 levels? Question. How many dummy variables will be introduced here? Answer. How many levels? 3 levels minus 1, so there will be 2 dummy variables. Okay? So there will be 2 dummy variables. Where did I get these 2 dummy variables? The formula is number of levels minus 1. So there are 3 levels here, A, B, C. So what will happen is now, let's suppose this is the brand of something. No? So what will happen is that, let me just clear all the drawings. So we're taking a look at brand. So what will happen, alphabetically A, B, C, no? A will now become the benchmark. Okay, so how many dummy variables will be introduced? Only 2. Why? Number of levels minus 1, so only 2 dummy variables. So if we have here the brand, no? We have here the brand, the variable brand. Let's say B, A, sorry, nahirapan ako sa B, A, C, C, A, B. So this is your column, class. This is your column. So since this is a factor, R will convert this into dummy variables in order for regression to work. Okay, how will it be converted? Since there are 3 levels here, R will introduce only 2 dummy variables. Sino-sino yung mga yung class? Alphabetically, A will come first. Alphabetically, no? So A will be used as the as the benchmark. So what will happen now is like this. So mag-i-introduce ngayon ng dalawa, no? B and C. Si B and C lang kasi si A will become the benchmark. So for example, this observation is B, magiging 1 siya dito, no? Kasi B2 di ba? 1, tapos si C, 0. Okay, how about A here? A. A is not B. Neither is it C. So 0, 0 yan. Si C naman dito, it's not B, but it's C. Okay, so take a look at this class. Just by 2 levels, just by 2 dummy variables, we're able to capture all the levels. Di ba? B yan, if it's B, then 1, 0 yan. If it's A, then it will be 0, 0. If it's C, then it will be 0, 1. Now notice, we're not putting here another dummy variable. Okay? We're not putting A also. Kasi class, what will happen is that there will be what we call a dummy variable trap. Okay, so it's almost time, class. Let me just quickly let me just interpret one here, and then we call it a day. We'll continue with this next meeting, no? So let me go to where's the yung regression result natin. Let me just explain that very quickly. Okay, here. Okay, here, class. Ito yung gender male. So what does this mean, class? How do we interpret this? Number one, it's statistically significant, di ba? 3 stars means that it's significant at the 0.001 level of significance. Okay, 3 stars yan, no? All right. Then take look, take a note, take look, no? Look, gender male. So this one, it's already telling us that the reference is female. So this value here is for male. So when you interpret this, you should interpret this in relation to the benchmark, which is female. So it means that on the average, male employees receive $1.76 more than their female counterparts, ceteris paribus. Okay? Why more? Because this is positive class. Okay? So why am I saying male? Because male here took the value of 1 and female took the value of 0. Female now is your benchmark, it's your reference, and you're saying male employees tend to have on the average $1.76 more than their female counterparts, ceteris paribus. Okay, and then here, for example, civil status, married and single. Now, since married comes first class, yun ang ginawang benchmark because M comes alphabetically first compared to single. So how do you interpret this? Okay, assuming that this is statistically significant, we're saying here, on the average, single employees receive $0.46 less. Now, notice it's less class because of the negative here, less than their married counterparts, ceteris paribus. Okay, although this is not statistically significant. Okay, so what does it mean to be not statistically significant? Okay, this could be 0 class. Yun ang ibig sabihin nun. It's possible that this value is 0. Remember that the null hypothesis here is that B6 is equal to 0. Okay, so it's possible that this value is not, when we say it's not significant, there's a chance that this is 0. Okay, and lastly, class, itong race white. The counterpart of white is non-white. So non-white comes first, no? Alphabetically. So non-white became your reference or your benchmark. So how do you now interpret this? On the average, white people receive $0.11 more than their non-white counterparts, ceteris paribus. But then again, class, it's not significant. So I was just assuming that if this was significant, you would have interpreted it that way. Again, on the average, white employees tend to receive $10 or $11 more than their non-white counterparts, ceteris paribus. Okay, all right. With that, class, let me. Okay. So we continue with this next meeting, class. Okay, stop.